Thanks for having me. So what I will do today is to take you back to industrial organization and revisit the Stackelberg model. And what we will do is to introduce regulation and see what happens with that particular model. So this is a joint work with Paxin Choi and Felix Muñoz Garcia. So what we will discuss is this sequential competition in which a Stackelberg model, we have a leader and a follower, and they have to decide their output. This type of output decision has been naturally observed in industries with intense innovation, in which the innovator is the one that becomes the leader, and has been historically well documented in marketing, transportation, and supply chain. More recently, we have observed this type of sequential output competition in high technology. Think about the energy storage, batteries, electric grids, among others. So there are two main characteristics of this type of competition is that they are rapidly expanding, but they are also producing pollution. And that takes us to our research question. So the main point in the paper is to examine whether or not we can use the same environmental policy as if firms compete simultaneously. So what we want to examine here is what are the output inefficiencies that are generated when the regulator thinks that it's facing an industry in which they are simultaneously deciding their output level, but in fact, they are sequentially competing. So what are the inefficiencies that the regulation introduced in that particular case? So more specifically, what we want to examine is how to regulate firms when they compete sequentially. So everybody knows that in a Stackelberg game, the leader produces more units than the follower when there is no regulation. And this is something that we call the output advantage. So now what we want to know is how this output advantage is affected by regulation. And at this point, what we will do is to examine we will express the output advantage into two different elements. One of them will be the first mover advantage and the other the cost advantage. And we will examine how regulation affects these two elements. I will also discuss the role of sequentiality, providing comparisons with simultaneous output decision with the Cournot model. And we will discuss a little bit the comparisons again, inflexible fees. In the model that I will present you, we will focus on the first best, in which the regulator is able to set an emission fee for the leader and for the follower, but we will compare and analyze what happens when there is inflexibility in the sense that the regulator sets only one fee for the leader and the follower. So in terms of the literature, regulation with simultaneous competition has been extensively analyzed. It was initiated by Buchanan in 1969. And after that, we have observed several papers examining symmetric cost, asymmetric pollution intensities, and price competition. So the literature is more focused on simultaneous competition and how regulation affects simultaneous competition, but is more silent about sequential competition. Now, in terms of Stackelberg games, the literature has focused more on having the regulation in the first place and then firms compete simultaneously, all right? What we are proposing here is something different. The regulator sets emission fees in the first and the second stage, and firms compete sequentially. So there is a leader and a follower. Another line of the literature has examined the effect of environmental regulation on profits. And here we find Porter and van der Leyen and Farsin, and they examine how regulation can promote more innovation and product quality, which at the end of the day increase profits. And also another part of the literature has examined how environmental regulation promotes corporate social responsibility or public image. We are proposing here an alternative channel for profit enhancing regulation, which is the attenuation of the first mover advantage and the cost advantage. So with that, here I will give you the outline of the presentation. I will start with the model. Then I will briefly discuss the equilibrium behavior without regulation. That will be the benchmark. I assume, of course, it's well known, so I will go a little bit faster then. And then I will spend more time talking about the case of regulation. Then I will start providing you comparisons. We will start comparing our results with the case of simultaneous competition. And I will develop some extensions in which we will examine what happened if we have an inflexible emission fee, if we assume several leaders and followers at the beginning of the model that I will present. I will consider one leader and one follower, but we will extend that to several leaders and followers. And then at the beginning, I will also assume that products are homogeneous, but next, we will ask what happened if products are differentiated. And finally, we will examine the followers' cost advantage. All right, so let me start with the model. Here we will consider a inverse demand function in which we have that capital Q is the aggregate product. The marginal cost of the leader and the follower are considered to be different, we are allowing for asymmetry. And what we will do, and this is an important definition of the marginal cost for the follower, we will define the marginal cost for the follower as the difference between the marginal cost of the follower and the leader. We will consider that the leader has a cost equal to 0. We will just normalize that, and we will define this as the leader cost efficiency. This is important because this will allow us to identify the leader's cost advantage at some point. So in terms of environmental damage, we consider environmental damage are produced during the production process. And as a consequence, there will be an environmental damage in the first stage when the leader produces, and an environmental damage in the second stage when the follower produces. This is a convex environmental damage, and this represents pollution intensity. It is assumed to be greater than 1/2 in order to focus on emission fees and not on subsidies, and to have positive emission fees. In terms of the time structure of the game that we will analyze, we will examine a two-stage game in which in the first stage, the regulator will set a first period emission fee, T1, and the leader responds choosing an output level. And in the second stage, the regulator again will set a second period fee, and the follower responds choosing the output level Q2. So now the output is sold at the end of the game, which is a main characteristic in a Stackelberg game. Notice that here I am presenting you the first best. Then we will explore different ways to set the emission fee. In terms of social welfare, which is relevant to identify the emission fee, we have that the social welfare in the second period is composed by consumer surplus, producer surplus, tax revenue, and environmental damage. Here we consider consumer surplus and producer surplus because the output is sold at the end of the game. Then in the first period, the regulator is able to anticipate what's happening in the second period, the social welfare generated in the second period, and will maximize the social welfare in the first period that will be composed by the environmental damage produced by the leader, tax revenue in order to make sure that it's revenue neutral, the fee that we are examining, and then the social welfare in the second period. We do not consider discount, or it's just assumed to be equal to 1. Okay, so the simplest case is the case of no environmental regulation, and we will use this as a benchmark to provide comparisons when we introduce regulation in place. So the typical Stackelberg game, we start operating by backward induction. The follower solves the following maximization problem, and we obtain the best response function for the follower. Notice something important to highlight here is that outputs are strategic substitutes, given the negative sign that we are observing in the best response function. The leader is able to anticipate what happens in the second stage and decide its output level, considering the follower's best response. And the output level, you can see that has a positive sign with respect to C, indicating that as the cost efficiency of the leader increases, then the leader produces more units. In addition, we will focus on C lower than 1/3 because we want to make sure that both firms are active. So in order to guarantee that the follower produces a positive output level, we require that firms are asymmetric, but not so asymmetric, right? Again, you can see that here for the follower, the parameter C enters negatively, indicating that as the leader becomes more efficient, the follower will reduce its output. So now, this is an important point because here we are calculating the leader's output advantage. And remember that our objective is to examine how regulation affects the leader's output advantage. So you can see that this difference is unambiguously positive. And now I will represent this difference as a line. So you will have the intercept and the slope of the line. When C is equal to 0, so when firms are completely symmetric, the leader's output advantage is mainly explained by the first mover advantage. Now, as firms become more asymmetric, the leader's output advantage is also explained by the leader's cost advantage, right? So as C increases, so as the leader becomes more efficient, then the leader's output advantage increases. So then the question is, how is each type of advantage being affected by the environmental policy? So then we will introduce environmental regulation and we will evaluate what happens with these two elements. And again, we will start operating by backward induction. So what we are doing right now is solving the game that I first presented in the model. So we have that the follower best response function slightly changes. We still have that the output are strategic substitutes, but here we have the emission fee that reduces the output produced by the follower in the second stage. Now, remember that in the second stage, the regulator is also setting environmental regulation for the follower. So the regulator will maximize the social welfare in the second period that I presented you and will identify a socially optimal amount. Once we identify that socially optimal amount that we can see that is unambiguously positive if and only if the leader doesn't produce too many units, so Q1 lower than this cutoff. And we can also observe that this socially optimal amount will decrease when the environmental damage decreases, which makes sense. With this socially optimal amount, we are able to identify the emission fee that will induce the follower to produce that socially optimal amount. So basically, you take this socially optimal amount, make it equal to the follower best response function, solve for T2, and you will obtain the emission fee that the follower faces. Next, we will examine how this emission fee changes when environmental damage changes, when the leader's cost efficiency changes, and when the output level of the leader changes. So what we observe is that the emission fee increases in D. So if the environmental damage increases, the emission becomes more stringent, but decreases in C and in the output level produced by the leader. So decreases in C, because if C increases, that means that the leader's cost efficiency is higher, the leader will produce higher units in the first period, and as a consequence, the follower will produce less in the second period, something that the regulator anticipates, and then sets less stringent emission fees. That's the reason that the emission fee will decrease in C. Now, Q1 has two effects on the output level produced by the follower. If the leader increases its output, it has a negative effect in the sense that the follower will have to reduce its output level. However, it has a positive effect in the sense that now the follower will face less stringent emission fees. So now we move to the first stage in which anticipating second period fee and output, the leader will solve its maximization problem and will decide its output level. And the output level, you can see that is presented here in lemma 3, is positive is if emission fees are not sufficiently high. It will decrease in the emission fee. So as the emission fee becomes more stringent, the leader will produce less unit. It increases in C. So as the leader becomes more efficient, will produce more units. And notice that it decreases in D. And the reason that the output produced by the leader decreases in D is because a higher environmental damage will induce higher emission fees in the second period. The leader anticipates this, knows that the follower will produce less units, and as a consequence, the leader produces more units. All right, so then similar than in the second stage, the regulator will identify the socially optimal amount. You can see that it's positive for all parameter values, the one that I am now highlighting. And with this socially optimal amount, we make it equal to lemma 3 to the output level produced by the leader, and solve for T1, we are able to obtain the first period emission fee, which is unambiguously positive. It increases in C, so as the leader becomes more efficient, we face more stringent emission fees, and it's also increasing in D, so as environmental damage becomes more intense, then the leader will face higher emission fees. All right, so now we want to understand the difference between the emission fee that the leader faces with the emission fee that the follower faces. And when we take that difference, we observe that that difference is unambiguously positive. So now we present that difference again as this line in which we have the intercept and the slope of the line. And the reason that we are doing that, we know that it's positive, but we want to learn more about how this difference is affected by the first mover advantage and the leader's cost advantage. So if we consider that firms are completely symmetric, so there is no cost advantage, C equal to 0, this difference is mainly explained by the first mover advantage. So the fact that the leader is paying a higher emission fee than the follower is just mainly explained by the first mover advantage. The regulator wants to address this first mover advantage. Now, when C becomes positive, then the emission fee faced by the leader increases more rapidly than the emission fee faced by the follower. And that's mainly explained because the regulator would like to address the leader's cost advantage. So now in terms of the leader's output advantage with regulation, remember that I presented before the leader's output advantage without regulation. Now we know we want to see how this output advantage is affected by regulation, and we can see that is unambiguously positive, increases in C and decreases in D. So what I will do next in order to examine the impacts of regulation on leader's output advantage is to calculate the change between these two changes. So this will be something that we will call the regulation-induced decrease in the leader's output advantage. And we find that this is positive for all parameter values, indicating that when we have regulation in place, the leader output advantage is affected. So the following figure that I will present, I think that clearly describes the dynamic that I am presenting here. You can see that the leader's output advantage without regulation this is the figure that I presented you at the beginning of the presentation. It was explained by the first mover advantage and the cost advantage. Now, when we introduce regulation, this leader's output advantage decreases. In fact, when firms are completely symmetric, the first mover advantage disappears. So regulation eliminates the first mover advantage. However, when firms become more asymmetric, so when the leader's cost efficiency increases, we still observe the leader's output advantage, although this leader's output advantage decreases when the environmental damage increases, which also makes sense because now we observe that the leader will face more stringent emission fees, which reduces the leader's output advantage. So now, in terms of profits, what we can say is that despite the fact of having regulation in place, the leader still receives more profits than the follower. However, we also calculated the effect of regulation on profits separately on the leader and the follower, and we observed that with regulation, the leader decreases its profits compared to the case of regulation, but the follower obtains more profits than in the case of non-regulation. So now, the next step, in order to calculate this output inefficiency that I was explaining at the beginning of the presentation, we need to compare results with the case of simultaneous output decision, with the case of could-not competition. So now I will not talk about leader and follower, but I will focus the analysis on firm one, right? So firm one was previously the leader in the Stackelberg situation. So now when there is regulation in place, we have that the output decision in a could-not game is negatively affected by the emission fee that these two firms are facing. And it's also affected by firms one cost efficiency. So now when there is no regulation and we calculate the firms one output advantage, it is just equal to C. It only depends on the firms one cost advantage. Of course, it doesn't depend on the first mover advantage because there is no first mover advantage in a could-not situation. So now when we introduce regulation, we have two cases. The first case is when firms are completely symmetric. So C is equal to 0. In this case, the socially optimal will be evenly divided among firm one and firm two, and we will have one emission fee for both firms. So both firms will face the same emission fee that induces that socially optimal amount. As a consequence, the firms one's output advantage when firms are symmetric will be 0. Then we will focus on the case when firms are asymmetric. So when firms one's cost advantage or cost efficiency is a positive. So then in this case, what we observe is that only firm one is active. Firm two is not active. So that's the socially optimal amount in which we have the most efficient firm producing and the inefficient firm doesn't produce. And then the emission fees that induce that results are the ones that I am presenting here. So in terms of firms one's output advantage, we observe that this output advantage is positive and it decreases in the pollution intensity or the environmental damage. So following the same steps that in the case of the Stackelberg situation, we calculate the regulation-induced decrease in output advantage. And we observe that that's positive now. It's positive if and only if the firm's one's cost efficiency is sufficiently high. Or in other words, this output advantage or the regulation decrease of the output advantage is positive if and only if firms are sufficiently asymmetric. This is different than in the case of sequential competition, in which we observed that that was unambiguously positive. So graphically, what we are observing now is that regulation affects firms one output advantage if and only if the environmental damage is sufficiently high and firms are sufficiently asymmetric. Otherwise, regulation will actually increase output advantage, right, in the case of simultaneous competition. This is different to the sequential approach. You can see that here we are comparing the firm one's output advantage in the case of the sequential, which is just this delta, and the case of could not. And we can see that in region one, they are different in the sense that regulation will affect firms one's output advantage or the leader's output advantage. However, when we have regulation, that doesn't affect actual increase firms one's output advantage when they compete simultaneously, all right? So in terms of emission fees, we also develop comparisons of the emission fee that firm one faces when it chooses output sequentially and when firm 1 chooses output simultaneously. And what we observe is that when the environmental damage is, well, for several environmental damage, but we require that the symmetry is not so high, the asymmetry between firms is not so high, then the firm 1, the leader in the case of Stackelberg, will face more stringent firm emission fees than the case of Cournot. The opposite is true for cases in which environmental damage is sufficiently high and firms are relatively asymmetric. In that case, the firm 1 will face more stringent emission fees when they compete simultaneously than sequentially. So now, at this point, we are ready to calculate the output inefficiencies. So what this figure is representing is the output inefficiency generated by the regulator when the regulator considers that firms are competing simultaneously when in fact firms were competing sequentially. So we are trying to measure this output inefficiency in terms of the output level that these two emission fees generate. So we can see that in this figure, so here we are measuring the output inefficiency, we see that this output inefficiency reaches the highest point when we have that firms are relatively symmetric. So you can see that the blue line is assuming a value of C. C, just to remind you, is the leader's cost inefficiency, so it's relatively low. Firms are more symmetric. So at this point, we will reach the highest output inefficiency and the environmental damage is intermediate. Now, if environmental damage is sufficiently high, you can see that for all these calculations, the output inefficiency decreases, which basically is telling us that doesn't matter if the regulator is considering some type of output competition, because the inefficiency that we generate from making a mistake and considering an output competition, a sequential, a simultaneous output competition, when in fact the output competition was sequential, is relatively minor, right? So summarizing, the output inefficiency is the larger, implying that considering Stackelberg fees is critical when these intermediate and firms are relatively symmetric. However, the output inefficiency is less relevant, implying that using Cournot fees do not give rise to a large inefficiency when firms are relatively symmetric, and D, especially D, is sufficiently high. So now, next, I will start developing different extensions in order to see how our results change when, for instance, we consider that the regulator sets a more inflexible regulation, right? So this can be rationalized as an administrative that is more bureaucratic, and there are more rigidities when selecting the emission fee. So what we will consider is that now the regulator select one emission fee for both firms, for the leader and the regulator, at the first stage of the need, right? So then we will identify the socially optimal amount. These socially optimal amounts are the same that those found in the first proposition that I was presenting you. And what we will try to identify is one emission fee that will induce this aggregate socially optimal amount. Of course, this emission fee is a suboptimal emission fee, is not the first best as the one that we were examining before. And what we obtain is that under an inflexible policy regime, the emission fee is the one that I am now highlighting. This should be minus, not equal. And this is an ambiguously positive as before, the same dynamic than before. The emission fee will increase with the pollution intensity. D will decrease in C and will satisfy the following. This emission fee that we found is lower now than the emission fee that the leader faces in the first best, but higher than the one that the follower faces when we were deciding an emission fee in each state. So now, in order to measure this inflexibility, what we will do is to create a linear combination between the emission fee that the leader faces when we consider the first best, T1 start, and the emission fee when fees are selected at the beginning and both firms face the same fee. So we will construct this linear combination and we will multiply that by mu. And mu will be denoting this regulator's flexibility. So if mu is equal to 1, then we will go back to the emission fee that I presented at the beginning of the presentation, the one in proposition 1. But if mu is equal to 0, then we go back to the emission fee that I just discussed, in which the regulator set this emission fee at the beginning of the game, and it's the same for both firms. So this is very useful because this will allow us to see how the degree of flexibility or inflexibility affects the leader's output advantage. So notice that we can do exactly the same arrangement for the emission fee that the follower faces. I will focus the analysis on the emission fee that the leader faces because we want to examine how the degree of flexibility affects the leader's output advantage. And that's presented with the following figure. So again, using the first graph that I presented at the beginning, we have the blue line, which is the case, this representing the leader's output advantage with no regulation. And then I am presenting you different leaders' output advantage considering different values of mu, which is the degree of flexibility. So when mu is equal to 1, we are in the case in the first best in which the regulator sets an emission fee for the leader and the follower in the first and the second stage. So now as the leader the regulator becomes more inflexible in the sense that is able to set only one fee, we can see that the effect of regulation on the leader's output advantage decreases. It's still below the case of no regulation, so we still the regulation still affects the leader's output advantage, but not so dramatically as when the regulator is able to set a different emission fee for the leader and the follower. All right, so then the next step is to examine how the results are affected when we have M leaders and N followers. All right, so when there is no regulation, what we know is that every leader's output advantage will be decreasing in the number of leaders or increasing in the number of followers. Now, when we have regulation in place, the regulator will seek to induce the same aggregate socially optimal output with more firms. So what she will do is to set more stringent fees on each firm. So then if we focused on the effect of regulation on the leader's output advantage, and this is a comparison, what we observe is that this effect becomes smaller when more leaders compete, thus ameliorating our previous results, the results that we presented with a single leader and a follower. However, this regulation-induced decrease in the leader's output advantage becomes larger when more followers compete, thus emphasizing the results that we just discussed. So then the next step is to examine what happened when we have product differentiation. So the way in which we are introducing product differentiation here is re-examining the demand, right? So now we have this beta that allow us to examine the effect of product differentiation. So what we show is that the leader's output advantage will decrease when products become more differentiated. And this is true with and without regulation. However, without regulation, the decrease on the leader's output advantage is more substantial. So what we are saying here is that the introduction of regulation will produce a smaller decrease in the leader's output advantage. So the way in which we can interpret this is as good becomes more differentiated, then the regulation-induced decrease in the leader's output advantage is smaller. So what we can infer from this result is that we then should observe a stronger opposition in terms of the environmental policy when firms sell homogeneous good than differentiated good, given that the leader's output advantage is more affected when regulation is in place when firms sell an homogeneous good. All right, and then what if instead of having a leader's cost advantage, we have a follower's cost advantage? So in this particular context, what will happen is that the leader will only benefit from first mover advantage, but not from the cost advantage. So in this case, what we found is that when firms are relatively symmetric, so C is relatively low, the leader will hold an output advantage under no regulation. But regulation will switch this output advantage to now a follower's output advantage under all parameters. Now, when C is intermediate, then the follower will hold an output advantage with and without regulation, but the policy will emphasize this advantage. So now what I will do is to summarize other, by the way, extension that we also developed was to examine what happened when the leader is cleaner or greener than the follower. And what we observe is that when the leader is produce less emissions than the follower, then regulation, of course, will affect in a more reduced way the leader's output advantage. So now, just summarizing all the results that we have been discussing, that I have been presenting you, with no regulation, what we observe is that the output advantage is larger in Stackelberg than in Cournot, and the output advantage decreases in the number of leaders, increases in the number of followers, and will shrink when goods becomes more differentiated. Now, when we introduce the regulation, we observe that the leader's output advantage will shrink for all parameter values, all right? Although we observe that this leader's output advantage will expand in the leader's cost advantage and shrinks when pollution becomes more damaging. And the reason that it shrinks is because regulation will become more stringent. So we also observe that this leader's output advantage decreases in the number of leaders, but increases in the number of followers. Now, in terms of regulation flexibility, remember that I was presenting, I was assuming that the regulator decides the emission fees in the first stage and both firms face the same emission fee. And with that, we were able to construct this linear combination and identify this ratio that help us to measure the regulatory inflexibility. So larger flexibility then expands the negative effect of regulation on the leader's output advantage. So as the regulator becomes more flexible, identifying different emission fees for the leader and the follower, then regulation will affect more heavily the leader's output advantage. In this situation, if the leader anticipates that the regulator is flexible, is able to set different fees to leader and follower, will be more opposed to regulation than in the case in which the leader knows that the regulator is more inflexible, setting emission fees. So now, the question was, why not just apply Cournot regulation? So forget about sequential competition, and then it doesn't matter if the regulator completely ignores the fact that firms are competing sequentially and just assume that they are competing simultaneously. So what we show is that some inefficiencies will be generated in terms of output inefficiency, and this inefficiency will be the largest when environmental damage are intermediate and firms are relatively symmetric. So what this implies is that in this particular context, when using a Stackelberg fees is the most critical for welfare, should be the most critical. In contrast, this inefficiency will be smaller when pollution is relatively damaging and firms are symmetric. So entailing that in this setting, the government actually, or the EPA can ignore whether the industry competes simultaneously or sequentially, and that, of course, will facilitate the design of the environmental policy. So this is all that I have for you today.